Okay, continuing with 7.4, we have a definition. So let's let vector u be equal to a comma b and vector v be equal to c comma d. So then the dot product and the dot product, that's what we're defining. Dot product denoted u dot v is the real number given by so u dot v, which is a comma b dot c comma d, is ac plus bd. So let's note so the dot product is the sum of the product of corresponding components, right? So we have a and c. Really? Why is it not doing a and c? Then we have b and d. So note the dot product is the sum of the products of corresponding components. So that is the horizontal component with the horizontal component, the vertical component with the vertical component, etc. Okay, so actually let me move this down a bit. Seems like I'm not spacing these out correctly. Not that it matters, it's just an aesthetic thing. Okay, so let's go on to an example. So for example, let's find the dot product or evaluate the dot product. For the following. Okay, so number one, let's say we have that u is the vector 1 comma 0 and v is the vector, actually let me not put a comma there. Let's have v be the vector 1/2 comma root 3 over 2. Notice I chose these because they're on the unit circle, not that it matters, but I want to show you something after I do this. So we have u dot v. Why does it always do this? U dot v. Okay, so what is this going to give us? This is going to give us vector u, which is 1 comma 0 dot. Now this is not composition because this is welcome to math. The same symbol means different things in different contexts. Okay, so in this context it means take the product of the horizontal components, 1 and 1/2, so 1 times 1/2, and add it to the product of vertical components, 0 times root 3 over 2. So we just get 1/2, right? Okay. So let's note something about this. That's the reason I made these on the unit circle. So note. Theta is equal to, well, 1 comma 0 is on the x-axis. 1/2 comma root 3 over 2 is at pi over 3 degrees, right? Or radians, rather. So pi over theta equals to pi over 3 is the angle between vector u equals to 1 comma 0 and vector v, where should I put this, equals to 1/2 comma root 3 over 2. Okay. Also note that 1/2 is actually cosine pi over 3. Okay, that's what I wanted to show you. So let's do another one. Hopefully this makes kind of sense. Move this up a bit. Does that look okay? Okay, hopefully. Okay, so number 2. Let's say we have the vector u. It's going to be at -1 comma root 3. And why do I keep on doing that? And vector v will be at 2 root 3 comma 2. Okay, so before we continue, let's note that if I take vector u and divide it by 2, so u divided by his magnitude will be on the unit circle, right? And I claim that his magnitude is 2. So -1 comma root 3 divided by 2 gives me something on the unit circle, so I was correct. So -1/2 root 3 over 2. So what this does is I know the angle, right? I know the angle at which u is. So let's call that phi. So phi, the angle phi for the u is -1/2. So that's in quadrant 2. So that's going to be 2 pi over 3. And now let's look at vector v. Where should I go? Vector v divided by his magnitude. Well, I bet I'd have to divide it by 4 to have a 2 in the denominator. So I claim that the magnitude of v is going to be 4. Root 3 comma 2. Let me underline this. Okay, so what do we get when we divide that by 2? By 4, we get root 3 over 2, comma 1/2. Okay, so let's call that angle psi. So psi corresponding to vector v, root 3 over 2 comma 1/2 is at 30 degrees or pi over 6. So what is the angle between these two? The angle between these two, if I go from 30 degrees to 120 degrees, that's 90 degrees, right? Or let me not use degrees. Let's use pi over 2 to be formal. Pi over 2 radians. Okay, so now let's get on with our dot product. So u dot v is going to be -1 comma root 3 dot 2 root 3 comma 2, which is going to be the product of horizontal components, -1 times the quantity 2 root 3 plus the product of vertical components. So that's going to be the square root of 3 times 2. Okay, that is, I have a negative 2 root 3 and a positive 2 root 3, which gives me 0. And is that equal to cosine of pi over 2? It is indeed. Okay, that's interesting. Okay, so let's note so what do I know about the dot product with respect to cosine of the angle between them? So given vectors u and v, we have that cosine of theta is going to be the dot product between the unit vectors in the direction of u and v respectively. So where theta is the angle between u and v, angle between u and v. And of course, I guess I should say it, u over the magnitude of u is a unit vector. In direction of u. And of course, v over the magnitude of v is equal to the unit vector in direction of v. Okay, so for example, so let's find the angle. Find the angle between vectors u and v. U and v. So number 1, let's say we're given that u is negative 5, 5. And let's have v be at 3, 0. So I could do this the way I usually did by figuring out, but I'm going to do it this way. Pardon me. I'm going to say cosine of the angle theta between them is going to be, well, it's vector u divided by the magnitude of u dot vector v divided by the magnitude of v. Okay, so we have that cosine of theta is going to be negative 5, 5. We're going to divide that by the square root of 5 squared, or negative 5 squared, which is positive, plus 5 squared. Then we're going to dot that with three, 0 divided by the square root of 3 squared plus 0 squared. have that cosine of theta is going to be, so 5 squared plus 5 squared, that's 50, or 2 times 25. So it's going to be negative 5 over 5 times root 2, comma 5 over 5 times root 2. When I divide in the magnitude divided by, well, the square root of 3 squared is just 3, so that's 3 over 3, comma 0 over 3. So what does this give us? This gives us 1 over root 2, sorry, negative 1 over root 2, comma 1 over root 2, which we could rationalize, but that's okay, dot 1 comma 0, which when we take the dot product gives us negative 1 over root 2 times 1. Okay, so what do we have? We have the cosine of theta is negative 1 over root 2. But what I could do is I could make that 1 into a root 2 over root 2 and rationalize. So this would give me negative root 2 over 2. So in which two quadrants is cosine invertible? Or better yet, at what angle is cosine negative root 2 over 2? And that would be when theta is a 45-degree reference angle in quadrant 2. So that's 3 pi over 4. Okay, that seems like a lot of work when I could have just plotted the two and seen the angle between them. But that doesn't build character. Or maybe it does. Maybe I'll just go ahead and do that. Why the heck not? Okay, so let's go ahead, and we had a negative 5, comma 5, and 3, comma 0. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so vector u was negative 5, comma 5. So that's along this diagonal. This is vector u. Vector v is at 3, comma 0. Yes, so it should be evident that the angle theta is indeed 3 pi over 4, because I'm at a 45-degree reference angle here in quadrant 2. So that would have been the easier way to do it, but I'm using dot product. Okay, so what's the next one? Number 2. Let's say we're given that vector u is negative 3, comma 3 times the square root of 3. And vector v is 1, comma root 3. Okay, well, I know that cosine of theta will be the unit vector in the direction of u. So u divided by his magnitude dot the unit vector in the direction of v. So v divided by his magnitude okay, so what do we get? We get negative 3, comma 3 root 3 divided by the square root of quantity negative 3 squared plus 3 squared times 3 dot. We have 1, comma root 3 divided by the square root of 1 squared plus 3. Okay, so what do we have? Well, how many 9s do I have? I have 4 9s in the denominator. So that's 2 times 3. So I have a magnitude of 6 for u. So negative 3 over 6, comma 3 root 3 over 6, dot. Okay, square root of 4 is 2, so 1 over 2, root 3 over 2, which is evidently, or should be clearly, on the unit circle. Let's make sure this first one is, so reducing, we'll have a negative 1/2 and a square root of 3 over 2. Okay, good. Dot. A positive 1/2 and a square root of 3 over 2. So what that gives us then is negative 1/2 times 1/2, to which we're adding root 3 over 2 times root 3 over 2. Okay. So what do we get? We get negative 1/4 plus, did I do this right? Well, let's see. Root 3 times root 3 is just 3, right? So that's 3 over 4. So what do I have? How many? 3/4 minus 1/4 is 2/4, or 1/2. So if cosine of theta is 1/2, cosine of theta is 1/2. What is theta? Well, where's cosine of theta 1/2? At 60 degrees. So that means that the angle must be pi over 3. But don't take my word for it. Let's actually see this. So let's go ahead and, should I plot those? Actually, it's better to, at this point, when we have unit circle guys, do you agree that phi corresponding to u is going to be at 2 pi over 3? I'm in the second quadrant. And psi corresponding to v, 1/2 root 3 over 2, that's going to be pi over 3. So yes, the difference, 2 pi over 3 minus pi over 3 is indeed pi over 3. Okay, so we did it. Okay, so let's do number 3. So for this one, let's say we have that u is going to be 2 times the square root of 3, comma 2. Let's have v be negative 5, comma 5 root 3. Okay, so I know that cosine of theta is going to be the dot product of the unit vector, pardon me, in the direction of u, and the unit vector in the direction of v. Okay, so cosine of theta will be, it's going to be 2 root 3, comma 2, divided by the square root of 2 squared times 3 plus 2 squared, dot. So what's vector v is going to be negative 5, comma 5 root 3, divided by the square root of quantity negative 5 squared plus 5 squared times 3. Okay, so what do we get? Well, how many 2 squareds do I have in the magnitude? I have 4 of them. So 4 times 4, and square root of 4 times 4 is 4. This is going to be 2 root 3 divided by 4, comma 2 divided by 4, which should leave me with something on the unit circle, dot. So 5 squared plus 3 5 squareds is 4 5 squareds. So that'll be 2 times 5 or 10. So negative 5 over 10, comma 5 root 3 over 10. Okay, so this gives us root 3 over 2, looking good, comma 1/2, that is indefinitely on the unit circle, dot negative 1/2, comma root 3 over 2. Okay, that's also on the unit circle. And I'll come back to the angles where those are later. Okay, so taking the dot product, we have root 3 over 2 times a negative 1/2. And we're adding that to 1/2 times root 3 over 2. Okay, so what do we get? We get a negative root 3 over 4, to which we're adding a positive root 3 over 4. So we get 0. Okay, so if cosine of theta is 0, then theta must be 90 degrees, right? So theta has to be pi over 2. And let's see if that's true. Let's go back up to where we had our unit vectors. So do you agree that phi corresponding to vector u is going to be root 3 comma half, that's pi over 6 or 30 degrees. And psi corresponding to vector v, negative 1/2 root 3 over 2, so that's 2 pi over 3. Okay, so from 120 minus 30 is indeed 90 degrees. So check mark, so we did it. Okay, I will see you guys in the next video.